Hello, today we'll be talking about the four-story office building with a basement. So the client for this project wanted a four-story office building with a basement, and the locations that we were given to choose from are Fort Myers, Florida, Cruz Bay, Virgin Islands, Greenfield, Indiana, Chicago, Illinois, Gainesville, Florida, Greensboro, North Carolina, and Atlanta, Georgia. At the end of the day, we decided to select Cruz Bay, Virgin Islands, which has a climate zone of 1A, which is very hot and humid. And we decided to select Cruz Bay because of the combined better peak cooling and heating loads, as we can see in this graph here. So Cruz Bay has a peak heating load of -5,981, and it has a peak cooling load of 883,196, which is better in comparison to the other options that we can see, especially when it comes to the peak heating loads. So this results in less energy demand from the system, ultimately meeting the goals of the client of reducing the budget costs. So the modeling methodology that we used uh, includes the weather files that were used in eQuest. So that entails for Fort Myers, the W/Palm FL bin. Gainesville, we use the Dayton FL dot bin. Chicago, we use the Chicago IL dot bin. Greenfield, we use the Indiana in dot bin. Greensboro, we use the Green S and C dot bin. Atlanta, we use the Atlanta GA dot bin. And then for Cruz Bay, we use the San dash Ju PR dot bin. And on the right, we can see a graphical representation of the fixed shading that was used in eQuest to simulate the trees that are going to be surrounding the building. So as far as energy efficiency measures, the first two that we used are the equipment power density energy efficiency measure. And in this EEM, we basically reduced the plug loads in the major areas of the building, which include the office open plan, office executive private plan, the corridor, lobby, restrooms, conference room, mechanical electrical room, and copy room. So throughout all of these rooms, we've reduced the plug loads, which reduces the strain on all the systems for the peak heating and cooling loads. The second energy efficiency measure that we use is the window area. So for this EEM, we decided to reduce the area of the windows throughout the building, which means that less heat will be entering as there is less window area for it to enter the building and whatnot. The third EEM that we decided to use is thermostat management. So in this EEM, we basically, in terms of when the building is occupied and when the building is unoccupied, we've manipulated the thermostat settings to reduce the strain on the system and reduce the need for heating and cooling in occupied situations, occupied and occupied. So the fourth EEM that we use is exterior wall insulation. So we made some changes to the exterior wall insulation. So that includes going from a metal frame to a wood frame. We've changed the exterior insulation from a R2 rated exterior insulation to a R-21 exterior insulation, which is a 3-inch polysulfonurate. So in terms of additional insulation, we've bumped up the R19 vat insulation to R21 vat insulation. And as far as the interior insulation, we went from no interior insulation to a 1-inch polysulfonurate with R-7 rating. So the summary of the data for all of the EEMs is as follows. So baseline, of course, we have our baseline and equipment power EEM. We have a energy savings from baseline of 2.06% energy savings. The window area EEM, we have a 4.45% energy savings from baseline. The thermostat management EEM, we have a 7.15% energy savings from baseline. And for the last EEM, we have an exterior wall insulation, which gives us an energy savings of 9.18% energy savings from baseline. So all in all, the selection of the location of Cruz Bay, Virgin Islands, with the implementation of the fixed shadings and the four energy efficiency measures, the owner should be able to reach his goals of energy efficiency while maintaining his budget with his focus on energy efficiency and reducing waste and reducing the peak heating and cooling loads. Thank you.